Introduction to Python. In this particular session, we are going to study about what is Python, why is it called as open source software, what are the different features of Python, what are the uses of Python, and how is it going to enable to do the basic operations of mathematics in Python. So this is a programming language which is being used by most of the developers to do some sort of machine learning analysis and the data science analysis. So moving ahead into this particular session, so we will be covering the topics of how the comments can be written in Python. So what are the different ways in which a Python variable can be mentioned over here. At the end of the course, you will be given with some sort of quiz to be answered, and you're also supposed to do some sort of simple operations on Python using the Python script. Along with this, we will also be looking into the installation of Python using Anaconda Navigator. Thank you. Moving into the session right now.
Let us learn something about Python right now. Okay, in this particular session, we are going to cover what is Python, what is an open source software, what are the features of Python, how to install Python, and what are the basic operations in Python. Now, without much delay, let us drill into this particular concept of what is Python right now. Python is an integrated object-oriented high-level programming language which helps the programmers to write the codes clearly and with proper logic. It helps the very programmers with a small and large-scale projects to do some sort of analysis and to take a business decisions. It is an open source software. Now, before moving ahead into the in-depth understanding of what this Python software is, let us understand for about a minute about what is this particular open source, right? As mentioned in the earlier part, so Python is an open source software which is object-oriented, which is easy to learn, and which is having the standard libraries within itself. So hence, it is been termed as a high-level programming language with simple and easy syntax and dynamic semantics. Now, moving ahead with this, what is open source software? The open source software is a platform that uses an open development process and is licensed to include the source code. So it helps you to develop your own source code, and it allows the other programmers to use the same source code. So hence, it makes easy for your team members to understand the code and it gets executed in the same format. The community of programmers can develop a new set of algorithms and can be sourced into this particular platform. Now, if you have a team of people who are working on a new algorithm, and those particular source code for that new algorithm can be incorporated into this particular software where it will be licensed to be used by others. It is a platform where users have the right to use the code, study the code, change and distribute the code. So hence, it is a platform where it helps your team members to execute the same code which you have written, and it gets executed in the same way. And if at all, if one of your team members want to change the code or want to change or update the code according to the analysis, so it helps you to do that particular process. And it helps you to distribute the same source code can be sent it across to all the team members for their referral. Right? So this is the example, this is the explanation for an open source software. There are different kinds of open source softwares which are available right now. To mention a few over here is nothing but your Jupyter Notebook, which we are going to use for the further sessions in Python. Spark, which is again one of the most important inbuilt functions in Python. Julia is another software which helps you to conduct this machine learning and data science. H2O is another platform which helps you to do this particular thing. So all these are open source softwares which are enabling you to go ahead and create your own code, create your own new algorithm, distribute the code, ask the others to use the same source code, manipulate the code and use that particular code over here. So hence, with this understanding of Python, if we just look into what are the features of Python. So as we have seen right now, one of the most and the first feature of Python is it is simple. The code has been written in a very simple language where each and every person can understand what the code is. It is portable. That means it can be distributed to all your team members for the updation, for the changes and for their referral. It is an open source software where it has the ability to go ahead and come out with a new algorithms where the community can contribute towards the upgrading of the script over here. And it can be embeddable with other softwares. For example, if you wanted to go ahead and come out with a beautiful visualizations, so there the Python can be incorporated over. And interpretation of the results is quite easy, because in the interpretation of the results, what happens over there is each and every line can be interpreted easily. It has a very huge library function where it has an inbuilt function for each and every operation. That's the reason it is called as a high-level programming language, where it has the capability of dealing with huge volume of the data. And it is an object-oriented programming language, as we have discussed earlier. So these are the features of Python. Now let us go ahead and then see how to install Python. Because for the further coming sessions, we will be writing a small script on Python. So hence it is very crucial to know how to install Python. In order to install Python, there is a URL link which enables you to go ahead and install Jupyter Notebook, which we are going to work upon by using Anaconda Navigator. So hence, click on that particular link. So the moment you click on that particular link, it will take you to a window where you have the clear step-by-step process, or a clear indication how to install Anaconda Navigator. So the moment you enter into this particular window, it gives you something called Anaconda Individual Edition, where it has an option to download. If at all, if you are using MacBook, then it is always preferred to go ahead and check for the installation of Anaconda Navigator for the Mac version. Right now, the one which I am displaying right now shows you about the Windows version. So hence, you can see a download button below Anaconda Individual Edition with Python 3.8 and 64-bit graphical installer. Hence, click on that download. The moment you click on the download button, there will be an exe file which gets executed, right? So hence, just click on that execution file and save the file, and entirely run that particular file. I am not doing so in my laptop because I have already installed Python in my laptop. So hence, go to that execution file and keep on clicking on next options till the execution file has been executed successfully. Once the execution file has been successfully executed, the moment you click on Anaconda Navigator at the start button, type for Anaconda Navigator at the start button, you will be seeing a green color circle. That gives an indication that your Anaconda Navigator app has been successfully installed on your system. Now, launch that particular app onto your laptop. So the moment you launch the Anaconda Navigator onto your laptop, it opens a new window of Anaconda Navigator, where you can see the CMD exe prompt, Jupyter Lab, Jupyter Notebook, Orange 3, PowerShell prompt, Qt console, Spider, GlueWiz, and RStudio. Now, what we are going to do is, for the further sessions, we are going to work on the Jupyter Notebook, because Jupyter Notebook is one such particular platform which helps you to have a clear computing. It helps you to edit each and every line of the code. So hence, under the Jupyter Notebook, you can see an option called Launch. So click on that particular launch option. So the moment you click on the launch option, it will take you to a home page of Jupyter Notebook, where you can see certain options mentioned over here representing all the documents on your laptop. The moment you look on the home page, at the right side of the home page, you can see a button called New with a drop down. So click on the drop down. There you can see something called Python 3. So click on the Python 3 over there. The moment you click on Python 3, it will take you to a script, a programming environment, where you can see in with some open brackets. So this gives you an indication that the Python using Jupyter Notebook has been successfully installed in your laptop. Thank you. Yes. Now coming to the basic operations in Python. As that we have seen what is Python, how to install Python, what are the features of Python, what exactly a Python can do, what are the operations that a Python can mention or can has the capability of doing. Now if you just look at this operations, basic operations of Python, it has the capability of doing or enabling the programmers to come out with the programming script from basic mathematics to till the wavelet transformations. Now, whenever I say that basic mathematics to till the wavelet transformation, under the basic mathematics, it has the capability of doing the basic operations like addition, subtraction, multiplication, and division. Now, combining with all these options, where the Python has the capability of coming out with the functions where if it is of a linear combination or of a non-linear combination, and has the capability of coming out with new algorithms of machine learning and neural networks. It also has the capability of going ahead and finding out the wavelet transformations by using the trigonometric functions of sine or cosine. Now, these are the operations which a Python is capable of doing at. Now, having a thorough understanding of this particular operations which a Python can do, let us look at what are the uses of Python. Now, the moment you come out with a Python or you do a coding on Python, it enables you to come ahead and go and develop a website, or a web development is one of the phenomenal usage of Python. It helps you to come out with a software development. It enables you to do some sort of mathematical operations. It helps you in dealing with the scripting, where you can come out with the script enabling the analysis process to go ahead with. Right? So these are the uses of Python. Now, having known about the uses of Python and having known about what are its features, can I write some sort of comments when I'm doing some sort of scripting in Python? To answer this question, yes, Python enables you to write some sort of comments. Now, how can we write a comment? How can we represent a comment? Because in any other languages, you don't have an option of writing comments over there while you are writing the script. But whenever you are dealing with Python, at certain parts, you need to understand what exactly you have done in that particular step, right? So that has been enabled with the Python. Now, while writing a Python comment, so the comments can be used to explain the Python code. For example, you might have added two different numbers. Now you need to represent that as a comment in your script, mentioning that this is an addition of two different numbers. So in such a case scenario, Python enables you to write some sort of comments. Now, before we drill down deeper into how the Python comments can be represented, okay, so let us have some sort of understanding about Python comments and what type of, how to represent those comments in the script format. Thank you. Now, let us understand how a comment can be written in Python. As I just mentioned you earlier in the session, the Python comments are the one which enables you to write some sort of explanation to the Python code. For example, if I'm adding two numbers of 3 plus 2, I have to write a comment over here saying that I'm going to do some sort of addition. Right? Now, the way in which you are going to give this explanation is nothing but your comment. Now, in order to represent this in a Python notebook, so the comments can be used to make the code more readable. For example, let us assume that I'm going to add and subtract, and I'm going to take a linear equation to solve certain problem. So in such a case, what I will do is I will be doing something like this, right? So which involves some sort of calculations. Now I need to, write a comment over here saying that I need to simplify this. Right? So this is nothing but a comment which enables you to understand what this particular code or what this particular operation is doing. Right? And the comments can also be used to prevent execution when testing the code. Right? Now with this understanding of how to write this, so in Python, the comment can be started with using hash symbol. The comments can be placed at the end of the line too. So what do I mean by this? For example, I'm just typing the same thing over here, but at the end of the line, I'm saying that addition. Right? At the end of the line also you can write the comment, and hence Python has the capability of understanding that the moment it looks at the hash symbol, it understands that it is a comment, not a syntax. A comment does not have to be text that explains the code. It can also be used to prevent the Python from execution of the code. For example, let us assume I have done two operations. One is 5 plus 3. The other one is 2 plus 6. I don't want the second operation to get executed. So in such a case, what I can do, I can add a hash symbol in front, so that the moment I add a hash symbol in front, it understands that this code need not be executed. Right? So this is this is how the Python understands the comment. You can also add multiple comments where you can also represent hash symbol for the multiple lines. So for each and every line, wherever you just wanted to add upon, you can add multiple lines over there. So this is how the comments can be added in Python. In the next session or in the next topic, we are going to deal with fine, I know how to do this mathematical operations, and what kind of variables does a Python can handle. So that will be continued in the next session. Till then, happy learning. See you in the next session, please. Welcome. Now we are going to discuss about Python variables, how to create the variables. So what are the types of variables that the Python can handle? Now coming on to the creating of the variables. So Python has no command for declaring a variable. If at all, if you want to save some value by mentioning it into a particular name, which is nothing but a variable, it understands that it is a variable which captures a certain value. Now what do I mean by this? For example, if I just wanted to mention that a is equal to 3, it saves variable a with the value 3. Right? So that is how the variable can be saved in Python. You need not declare any variable over there saying that if at all, if you want to save a number, this is how the name of the variable should be, nothing like that. Now, a variable can be created the moment you first assign a value to it. So the moment immediately if you want to assign a value, you can create a variable. And variables do not need to be declared with any particular type and can even change the type after they have been set. For example, I just want to mention a is equal to 1.5 as an integer, right? So in such a case, we can change the type of the variable. Or else I might be writing something like a is equal to, it is taking a price of the product, right? Now where this is a text format. Now this text format can also be converted into some other format, which we are going to see what are the different data type formats that the Python can handle, right? So hence, in this particular thing, the variables are being captured at the very first whenever you start assigning the value. So that is the capability of Python variables over here. Thank you very much. Now you're going to have a set of questions which you are supposed to answer and move to the next session. Thank you all. Happy learning. See you in the next session. Welcome everyone to the session on Python basics. In this particular session, we are going to cover about the basic operations done by Python, which falls under the 4 categories. One is operators, flow controls, functions, and the file handling. This session talks about Python operators. Operators are used to perform operations on variables and values. Whenever I talk about the variables are nothing but the columns. So Python has divided the types of operators into various types. Under that, those types of operators fall under the arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. Every type of operator has its own applications in Python. Moving ahead and learning in detail about these operators will be continued in the next sessions. Now, let us learn about what are arithmetic operators. Arithmetic operators are those which does the basic mathematical calculations. So whenever you just take arithmetical operators, the basic operations that we do in mathematics are addition, subtraction, multiplication, division, modulus, and exponentials. Now, whenever you are using an operator of plus, that means whenever you are going to add up the two different numbers by adding the addition operator, you are going to use the symbol plus. Whenever you wanted to subtract two numbers, you will be using the symbol of minus even in Python. Whenever you are going to work on multiplication, you'll be using asterisk. Whenever you apply division, it is the slash symbol which will be used. Whenever you are, taking the modulus of a number, that is converting even, or taking the absolute value of a number, we use percent.
for exponential value, that is like x square or x power 4 or x power cube or x cube or x power 5, something like this, to get the exponentials, we use two double asterisks or two asterisks. So these are the basic arithmetic operators which a Python can do. Now, in the following the session, we will be going ahead and looking at this arithmetic operators, how it can be done practically on Python. See you in the practical application of this arithmetic operator in Python in the next session. Thank you all. Let us go ahead and see how can we perform these operators in Python. The moment you open the Anaconda Navigator and launch the Jupyter Notebook, this is how the whole page of the Jupyter Notebook looks like. Click on the new button and launch Python 3. The moment you launch Python 3, it will be taken to a new window where it is getting processed with the command line. Now this is the place where you can see the command line of Jupyter Notebook. Now we will go and apply all these operators and how can we do these operations in Python. As we discussed in the last session, when it came for writing a comment in Python, we can add a hash symbol and write a comment. Now I'm doing addition of two numbers. Now in order to do the addition of two numbers, I need to go ahead and use the plus symbol. I'm going to add the numbers 3 plus 4. In order to run this command, generally in other languages we use enter. Here you can use this particular run option over here to enter it out, or you can do shift enter to run this command. So the moment I do the shift enter, you can see a line mentioning out representing the sum of two numbers is 7. Similarly, let us go ahead and subtract the numbers, subtract two numbers. So in order to subtract the two numbers that I'm going to consider are 10 minus 6. Right? Let us go ahead and find it out, the exponential function. So the exponential of 4 and 2. That is, I wanted to find the 4 square. So that's what I want to do here. So exponential, the square exponential of 4. So what I'm doing here, 4 double asterisk. Let's see what it obtains. Yes, the 4 square is 3. So I wanted to know the cube value of 3. Okay. So what I do, 3 asterisk 3. So it gives you 27. I wanted to go ahead and divide the numbers. So I wanted to know what is 24 divided by 8. It's 3. Okay. It's not that you can add only the numbers, we can add the decimal numbers too. Let us try with this. Yes. Okay. So you can also multiply the two decimal numbers. Yes. So this is how the arithmetic operators can be used in Python and can be extracted. So in the further session, you will be having some sort of assignments which you need to work upon and perform these operators. Till then, thank you all. Having understanding about the arithmetic operators, we are going to study about the second type of operators which are called as the assignment operators. Let us go ahead and look into how the assignment operators can be used in Python. Assignment operators are those which are used to assign certain values to the variables. In the earlier arithmetic operations, we have seen that if we want to add two numbers, we were directly giving the two numbers in Python and we were asking them to add, mentioning that 3 plus 5, where if you add, you should get the output as 8. Now, in the assignment operators, generally what we do is, we will assign some value to certain variable and that variable will be continued ahead to extract the value. For example, let us assume that let x take the value of 5. I wanted to find y which is equal to x plus 5. Literally, if you just take this example, now we know that x is equal to 5 and hence simplifying this equation, y will be taking the value of 5 plus 5. That means the number 5 will be taken in the place of x and hence y is equal to 10. Where you are doing, what exactly you are doing here is, you are adding a number to the assigned variable. Hence these are called as assigned operators. Just like similarly, however I'm adding, similarly I might wish to subtract the numbers. In order to go ahead and subtract the numbers, what I here is, I will define let a is equal to 6. Find b which is equal to a minus 4. Manually, whenever you just solve this, b will be equivalent to 6 minus 4, b will be equivalent to 2. Similarly, you can do all the operations over here. Now, in this particular table, you can see the various types of operators and what is the example for this and how relevant to this is. Now, if you just look at this particular equal to operator, x is equal to 5, it assumes that x should save the value of 5. Now x is equal to 5 says that, so you are adding a number 5 to the x value and that will be stored under x. That means the moment you just take this, x is equal to x plus 5. So whatever the x value you are going to consider, so it will be stored under x. The minus symbol carries the subtraction. Asterisk symbol carries the multiplication. Slash symbol carries the division. Cap carries the square. And greater than carries to compare the two numbers. So this is how we are going to have the assigned operators. In the coming session, we will be implementing 2 to 3 assignment operators on Python. Now let us go ahead and implement the assignment operators over here. Now, first I'm going to do the assignment operator of addition, where I'm saying that x is equal to 5. The moment I say x is equal to 5, Python remembers that x carries value of 5. Let us go ahead and check this right now. I said x is equal to 5. Let me execute this. Okay. The moment I type x, that means I'm asking that what are you calling in x right now? Okay. If I do shift enter, it tells me that right now I'm saving a number 5 at the place of x. Now let us assume I wanted to take y is equal to x plus 5. That means for the existing x value, I wanted to add with one more number, that is 5, and this value has to be stored under y right now. Has to be stored under y right now. Let me execute this. So the moment it got executed, it gives you a number in 3 something else. But I'm unable to see the number here because I did not call for y over here. The moment I call for y and enter, it is giving me 10. Similarly, what I can do here is I can call for z and add all this together, okay, with some number. Let me call for it again. Yes. So 10 plus 5, 15 plus 2 is 70. Similarly, you can do the assignment for the subtraction too. Okay. So let us go ahead and do the subtraction over here, saying that B should contain, okay, this with that. Right. This is how you can do the operations over here by taking the numbers. Let us try with this here by taking the numbers. Let us try with this, with the division. So I say that A is equal to 10 divided by 2. Okay. A. So it gives me 5 over here. Now what I'll do here is I want C, which is A divided by 2 again. So that means 5 divided by 2, which should be around 2.5. Let's see whether it fetches 2.5 or not. Yes. Okay. So this is how you can go ahead and do the assigning operators. So what I'm doing here, whatever the value I'm going to get, I'm asking the Python to store at one particular variable, which is nothing but C. Right? So this is how you can work on with the assignment operators. See you in the next session with the different kinds of operators. Thank you. Let us try to understand the third type of operators, which are called as comparison operators. Now, what are these comparing operators? They are used to compare two values. I have x as a particular value and I have 1 to be stored in one particular value. Now, I just wanted to check whether x is equal to y. In the same way, I have a certain value carried in x and I have a certain value carried on in y. I wanted to find whether x is equivalent to y or whether x is not equivalent to y, whether it is greater than or less than or greater than or equal to or less than or equal to. Now, what do I mean by this? Now, let us assume that I'm taking x is equal to 6 and y is equal to 4. Now, I want to compare these two values right now. Whenever I need to compare, what is the first comparison? I wanted to find it out whether x is equal to y. Now, if x is equal to y, then it should be true. If x is not equal to y, then it should be false. This is what comparison we do, right? So now let us go ahead and implement this comparison parameters on Python. Yes, let's go ahead and compare the variables. Whenever there is a comparison operators, generally what I do, I try to compare two different values, right? Now let us assume I'm giving a value of 5 to x and I'm giving a value of 6 to y. Now I wanted to find it out. Whether the value of x is exactly equal to 5. If it is exactly is equal to 5, it should fetch me true. It is not, it should fetch me false. It says true. Let me try and ask whether x is equal to of 5 and y is the value of 6, and obviously x is equal to y is a false statement. In the same way, now let us define. I'm defining z is equal to 5 exactly. Okay. So I'll ask whether x is equivalent to z. It says true. So this is how we can go ahead and compare the two different variables by taking certain basic operations. Now let us assume I wanted to find it out whether x is greater than z. It says 0. Right? because x is carrying 5 and it's greater than z is 0. Now similarly, I just wanted to check whether x is less than or equivalent to y. Yeah, true, because my x has a value of 5, whereas my 6 has a value of 6. Y has a value of 6. So hence it is true. Right? So this is how you can go ahead and compare the operators whenever you are comparing two different values or two different variables. In the next one, we'll go ahead and learn about logical operators. Till then, happy learning. See you all in the next. Welcome to the third operators, which are called as logical operators in Python. When it comes to the logical operators, these are used to combine two conditional statements. There are different types of operators. The most frequently used operators are AND or NOT. The operator AND returns the true value if both statements are true. For example, if x is less than 5 and x is less than 10, then it returns a true value if your statement is to find it out whether x is less than 10. It happens only when both the statements come true. Whereas if you just look into the OR statement, it returns a true value if either of the statements is true. X is less than 5 or x is less than 4. If either of these statements are true, then it gives you the true value. NOT, it reverses the else. That means it returns false if the result is true and it returns true if the result is false. Hence, it has been represented as NOT of x less than 5 and x less than 8. Now, having a brief understanding of these three kinds of operators, let us go ahead and look into each and every operator in depth. Moving into this particular AND logical operator. Let us understand how this AND logical operator works. Let's assume that you have x and y. AND logical operator says that if the both statements are true, then it returns the value as true. If any one of the statements is false, then it doesn't return the statement as true, instead it returns as a false. Now, if x is equal to true, then if this condition is true, it goes and verifies whether y is equal to true. If y is equal to true, then it says that it is a true value. If the x is not equal to true, if this condition is not true, it returns false. Now, x is equal to true and it verifies y is equal to true, and if y is equal to true is not equal to true, then it verifies as false. That means whenever you look at this AND logical operators, these logical operators come to a conclusion based on the first expression. If the first expression is evaluated to be false, then the further expressions are not evaluated. Let us try to understand this by using one particular example. For example, I wanted to check whether x is equal to 10 and y is equal to 10. Now, I wanted to verify a statement whether x and y are greater than 0. This is what I want to verify. Let us try to understand this logic by taking a flowchart how we have seen earlier. So I have x is equal to 10 and y is equal to 10. I'm using an AND statement here. First, it goes ahead here and verifies whether x is greater than 0. Now, if this condition is true, it goes ahead and verifies whether y is also greater than 0. If y is also greater than 0, if this condition is true, it gives your output as true over here. If the condition is false, it gives as false. Similarly, if it fails to prove the condition over here, it gives as false. This is how the logical operator of AND works. Continuing this session, we will just apply the same logical operator on Python, and then we'll see how this works over there. Let us go into the Python session right now. Let us see how we apply the AND operator in Python right now. I'm starting out saying that I'm using AND operator, okay? And for this, I require to feed in the values. I'm giving that a is equal to 10. So that means a has been assigned the value of 10. B is also equal to 10. And C is equal to minus 6. Remember, once you assign these values, you need to execute the code by pressing the run button on the Python notebook, or you have to use shift control. Now I have to verify a statement. Now, what is the statement I have to verify is the statement for verification is that if A is greater than 20 and B is greater than 20, then it has to give me that it is correct. The statement I want to verify whether this statement is correct, or else it should give me the statement as false. Okay, so let's go into this. What I'm giving here, I'm giving an if condition. If A is greater than 20 and B is greater than 20, then print, what do I want to print it as? Print the statement is correct. Else, print statement is wrong. Okay, so what it does right now, it verifies whether A is greater than 20. But what is assigned value for A? It is 10. So the very first itself, it has failed to identify, right? So hence what it should do, it should give me an answer saying that the statement is wrong. Let's see whether it gives the same statement or not. Yeah. So the statement is wrong here. Okay. Now let us understand one more here. If A and B both greater than 0, okay, then I want the statement to be correct. Okay. So what I do, I'll do the same thing over here. I'll take it. So instead of this, what I want to verify is A greater than 0 and B greater than 0. Then print the statement as correct, else print the statement as wrong. Now according to what it should do, it should give me the statement as correct, right? Let's see whether it fetches me the same. Yes, the statement is correct. Okay. This is how you can implement the AND statement in Python. Let's see one more example with a little complicated thing. Okay, can I add these statements over here? I wanted to see if A is greater than 0 and B is greater than 0 and C is greater than 0. Okay, then I want to print the statement as the numbers are greater than 0. It's not required that always you have to give the else statement. You can just give with the if statement too. Okay. Or else what I can do, see it got executed. Or else what I'll do here, I'll just add upon the else statement here. Else, what is it I want? I want print saying that at least one number is not greater than 0. At least one number is not greater than 0, since I have C is equal to -6, right? So A greater than 0, B greater than 0, C greater than 0. Okay. Now I'll just execute this command. Yes, it says that at least one number is not greater than 0. Now let's assume, let's assume that D is equal to 8. Okay, and I wanted to verify instead of C, I want to verify with D. Okay, now what it should return me? It should return me saying that all the numbers are greater than 0, right? Let us copy the same thing over here. Instead of C, what I'm doing, I'm taking D. Okay, now I'm executing this command. Fine, let me see. Okay, I did not execute this. That's the reason it is changing this. Okay, once I execute this, let me go ahead and execute this command right now. Yes, see, the numbers are greater than 0. This is how you can implement AND statement in Python. In the next session, we'll be going and learning in detail about how can we implement OR statement. See you in the next session. After looking out into the AND operator, now let us go ahead and understand how Python can handle OR operator. Now going ahead with this, the OR logical operator works similarly as an AND operator, but when it is extracting the output, it wants either of the statement be true. Now what do I mean by this? Whenever X is taking the value of 10 and Y is taking the value of 5, if at all, if you want to verify a statement saying that whether X and Y, sorry, we are using X or Y is greater than 7. If at all, if you want to verify this particular statement. Now, how does the OR operator work? It takes X or Y. At first, it finds out whether X equal to true. That is, the statement is true. What is the statement over here? X should be greater than 7. If you see here, X is carrying the value of 10. So hence, obviously, this is greater than 7 and hence it should exhibit the value as true. This will be the output generated whenever you are extracting this statement. Now let us check the statement over here. Now instead of checking for greater, let us assume that X or Y is less than 7. Now if I take the same example over here, now I wanted to verify the statement whether X is less than 7, whereas this statement is false. The moment the statement is false, it goes and verifies whether the same condition or the same statement is being satisfied with y value. So if y is less than 7, if that is true, it gives you the output as true. This is how the OR logical operator works. Now, the point which I want you to make a note while we are applying the OR logical operator is OR logical operator returns true if either of the conditions are true. Whereas if you just look into the AND operator, both the conditions ought to be true here. In OR, either of the conditions are to be true. It means either x less than or equal less than 7 or y less than 7. So out of these two conditions, if any one of the condition is true, then it returns the value as true. This is how the OR logical operator works. Now, let us go and implement the same OR logical operator in Python. Go ahead with the practical session. Thank you. Let us come and let us go ahead and implement the OR operator in Python. So I'm starting saying that I'm going to implement the OR operator. Now what am I doing in the OR operator is I'm saying that let A take the value of 10, B take the value of 20, and C take the value of minus 15. I'm storing, that means I'm assigning the values to the variables. So hence this turns out to be an assignment operator, right? So hence I'm assigning. Now once I assign the value, I wanted to verify a condition. Now what is the condition that I want to verify is if A is greater than 5 or B is greater than 5, I wanted to print the statement as both the values, let me write A and B are greater than 5. Okay. Else, I want to print this as both A and B are less than 5. This is what I wanted to implement. Okay, let's see what if it is. Now we are verifying whether A is greater than 5 and B is greater than 5. Either of the conditions are true, it should say that both A and B are greater than 5. Okay, let's see. Yeah, it says both A and B are greater than 5. Fine, I know that it's a very straightforward condition. Now let's compare the same. If A greater than 5 or C greater than 5, because I know that B greater than 5, right? Now let's assume, let's see whether Python can implement it properly, right? Print one of the values is greater than 5. So I just wanted to print that one of the values is greater than 5. Else I want to print saying that change. Okay, let us write like this. Okay, both the values are less than 5. Okay, this is what I wanted to print. Now we know that A is greater than 5, but C is not greater than 5, right? So hence, what should be the output? It should return us saying that one of the values is greater than 5. Right? Let's see. Yeah, it clearly says that one of the values is greater than 5. So this is how generally we implement our statement in Python. Looking forward with. Let us implement the NOT operator, which is the last operator under the logical operators. When you just go ahead with the NOT operator, the NOT operator gives you the results in a reverse order. It returns the result to be false if it returns false if the result is true. In the same way, it returns true if the result is false. Now let us go ahead and understand the statement. It starts with not x. So hence, if x is equal to true, yes, if that condition is true, then it gives you as false. If this condition is false, then it gives you as true. Now let us assume that we have a value A is equal to 10. Now, I wanted to understand whether 10 is divisible by 5. And I have a value is B, which is equal to 6. In the same way, I just wanted to understand whether 6 is divisible by 3. Now, these are the things which I wanted to understand. Or else, let's go ahead with one statement right now for a better understanding. I take A is equal to 10 and I just wanted to verify whether A is divisible by 3 and 5. This is what I just wanted to verify. Now, what it says, if it is not x, if it is not 10, if this condition is true, yes, this is not 10. Is it divisible by 3? Okay. If this condition is true, then it results as false. If this condition is false, then it results as true. Now, instead of looking into these things, now let us go ahead and try to implement it practically. moving into the Python practical session. Let us implement the NOT operator, which was a little confusing earlier. Okay. Now I'm just assigning a value. A char is the value chain. Okay. And I'm just giving one condition here. Okay, let me run this. I'm giving the condition. What is the condition? If not A. If it's not A, print the Boolean value. Boolean value of A is true. Okay, this is what I wanted. Now I'm giving a condition here. If not, check for whether A can be divided by 3, and if it gets divided by 3, it gives me the value of 0. Or if A is divided by 5, it gives me value of 0. So now if you see here what we are doing, we are having A as 10, and if the 10 is divided by 3, whether it is giving the value as 0, or if the same 10 is divided by 5, whether it is giving the value as 0, and we are giving the condition here saying that print 10. Okay, let me write this. A is equal to 10 is not divisible either by 3 or 5. Okay, else I want to print the condition saying that A is equal to 10 is divisible by 3 or 5. This is what I'm verifying. Now if you see here, A is divisible by 3 doesn't give you the quotient as 0, but when it is getting divisible by 5 gives you 0. Right? As we are using the OR statement here, it should give 1 saying that is equal to 10 is divisible by 3 or 5. Let's see what it gives us. Yes. A is equal to 2 is equal to 10 is divisible by 3 or 5 since as it is the condition of R. So let's go ahead and implement AND over here. Okay. Now I'm changing this. If not A divisible by 5 and A divisible by 10. Okay. If all these things, if it is coming to be 0, okay, I want to print the condition saying that it is divisible by both 0 and 10. Sorry, 5 and 10. 5 and 10. Okay. Else, I want to print the result as not divisible. Now, as see here, now as both numbers are capable of dividing this, it should give us the result saying that it is divisible by both 5 and 10, right? Let's see. Okay, it is saying it is not divisible since A divided by 5 will give you 1. Let's change this and then look into. I don't think so. That should have problem. Yes. Okay. This is how the and or along with NOT operator can be implemented. See you in the next session with the identity operators. Till then, happy learning. Thank you.
What are Python packages? Now, moving ahead into this, the topics that will be covered in this particular session include what a module is, and we also see how to create the modules in Python, what is a package, and how can we, what are the existing packages in Python, and what is its functions. So without delay, moving into the first one. So what defines a module is? Module is a simple Python file that contains collection of functions and variables. It carries the extension of .python. That means whenever you are going to carry out whenever you are going to create a module, all the modules will carry the extension of .py. It is an execution file which is used to organize all the modules. The collection of all these modules leads to a package. Now, for example, I may require addition, subtraction, multiplication, and division to be done. So whenever we are doing this, generally what I do is I try to create a module out of this. Whenever I am trying to create a module out of this, I will keep the module name as math with an extension of .py. So hence it will be math.py. So the moment I'm calling upon for this particular module math.py, I can do addition, I can do subtraction, I can do multiplication, and I can do division. So this is how the module works. Now, how to create a module? Now, in order to create a module, you need to define the module first that you wanted to create and name that particular module. So whenever we are doing so first you have named the module. So in the next step, what you do, you import the named file as a demo module or whatever the file you wanted to, module name you wanted to give it as, and call for your first module. So generally, to import the module into Python, we will be using the word Python over here. We will be using the word import over here. So later in the next session, we will be talking about how to create a module in Python. Till then, happy learning. Python packages. In this module, we are going to learn about what are the existing packages in Python. So, and coming to the definition and the intro session of Python packages, package is a collection of modules. As we discussed in the last session, we said that if I create a module with multiple operations, then all those particular multiple operations will be stored under a package. Okay, so this package is a collection of modules. Depending on various types of operations, we need to import the requisite package. Now, to give you a still more clarity on this, let us go ahead and understand what are the inbuilt packages in Python. Of course, there are a very large packages which are existing in Python. The most popularly used and frequently used packages are being mentioned over here. One is NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, and TensorFlow. So let us go ahead and understand these particular packages in detail. Now moving into the session, what is NumPy? NumPy is a package which will enable you to do some sort of numerical operations. Now, whenever I wanted to do the numerical operations, what kind of numerical operations can I do? For example, I wanted to do addition, subtraction, multiplication, which will be under the arithmetic operations. I may need to carry out some sort of regression analysis or correlation analysis or some sort of statistical techniques which will be done by using statistical operations. So there will be nominal variables which will be operated with. So hence you require bitwise operators. I may wanted to copy and view the arrays. So whenever you wanted to view the data in the form of arrays, then you require the NumPy package. And stacking is another module which we'll be learning in detail in the further session. So matrix operations of addition, matrix subtraction, matrix multiplication, all the matrix operations can be carried by calling upon for the NumPy. Linear algebra. So I just wanted to come out with a linear equations. So in such a case, I used to use the package of NumPy. And coming to the mathematical operations of differentiation, integration, all this also can be carried on using NumPy. Searching the number of observations, sorting out the number of observations from either from descending order to ascending order or from highest to lowest or lowest to highest, and counting how many number of observations we have. So all these numerical operations can be carried on using NumPy package. Now, whenever we are just wanted to go ahead and look at this particular packages, we will see some of the operations how we can do it on Python using the NumPy in the practical sessions of Python. Okay, so till then, happy learning. Welcome to the practical session on using the NumPy package. We know that NumPy package helps us to do some sort of mathematical operations and searching, sorting, broadcasting, right? So statistical operations, arithmetic operations, and matrix operations. To see how this works, what we are going to do is we are going to look at some of the matrix operations and then see how it works. So in this practical session, we try to create an array and print its array. And whenever we are printing it, we just try to extract the type of the array, dimensions of the array, what is the shape of that particular array, and what is its size, and the type of elements in an array. So let us go ahead and implement the same thing right now. Let's go ahead and create an array object right now. So before you create an array object, it is, in order to handle the arrays, you require a NumPy package. So hence, import NumPy, which is in a short form as NP. So hence, I'm going to create an array object. So let the array object be mentioned it as array is equal to np dot array of 1, 2, 3. This is one object. And I'm creating one more with 4, 5, 6. So let us run this. So the moment I run this, an array is being created with 1, 2, 3, and 4, 5, 6. Now I wanted to print the type of array object. So in order to print the type of the array object, I'm using the print command, print, and I want array type, okay, which is to be extracted by using the type command of array. So let us run this. So the array is a number array. Okay. Now I wanted to understand the array dimensions. So what are the dimensions of array here? So hence to do this, print the dimensions of array, print the dimensions, and I want this dimensions to be extracted by using the command array n dimensions. So it has 2 dimensions. That means it has got 2 rows over here. Similarly, I wanted to print the shape of an array. So hence I'll be using the same command of shape. So print shape. Okay. So by taking the command of array dot shape and run it. So the array has the 2 rows with 3 columns. That's what the shape means. Now again, I wanted to find it out. The print elements in an array. That means how many observations or how many numbers in a row and how many numbers in a column. That is what I wanted to find it out. So print the elements, and I'm extracting this by using the command data type. So D type. So it gives that it is an element or the data type with an integer type. That is, as we have numbers, so it identifies that it is an integer type. So this is how we go ahead and create a single array by using a NumPy package. In the next practical session, we will be just going ahead and seeing it out a single operations with the addition, subtraction, and
In the first session, we have seen how to create a single array and how to extract its dimensions and the shape. And in this particular session, we are going to look at the single array operations. So what are the basic operations that can be done by using a single array? So hence I'm defining this as an operation, single array operations. I have already imported the NumPy package over here. So hence I'm defining the object A, which is an array of 4, 5, 6, 7 elements. Now on these particular elements, I just wanted to go ahead and do the basic operations of addition and subtraction. So I'm going to add 1 to each element of this array. So, and I wanted to get it printed. So what I'm doing here, so I'm saying that print adding 1 to each element, and I'm saying that A plus 1. So hence if I run this command, okay, fine. Let me just try to close this parenthesis, end of the line parenthesis. I should try to close it. So print adding 1 to every element. So hence I need to remove this. Yeah. So this is how it captures. And I wanted to subtract 2 from each element. So to do so, what I'll do, I'll take the same, okay, and again I'll print it. Instead of saying adding, I'll say it as subtract. I want to subtract 2 from each element. So I'll mention this as A minus 2, and hence it should give me, I'm sorry, A minus 1. So it is A minus 2. So it is going, so 4 minus 2 is 2, 5 minus 2 is 3, and 6 minus 2 is 4, and 7 minus 2 is 5. Now similarly, if I just wanted to multiply by 5 each element, then I'll be using the same command, but instead of taking this as addition, I'll say that multiply by 5 to each element. So hence I'm going to use the symbol asterisk because that's the symbol which is being used to, yes. And in the same way, if I want to take the square of the elements, so what I'll do, I'll print square of the element, and to get the square of the element we use double asterisk. So if I run this, so this is how we do the single array operations with the basic operations of addition, subtraction, multiplication in Python. In the next session, we will be going ahead and looking into the matrix multiplications and matrix addition. Let us go ahead and do the matrix operations right now. In order to do the matrix operations, first of all, I need to create a matrix. Let X be a matrix with an array of, okay, elements. As of our, as it is a basic understanding, I'm taking only 2 rows and 2 columns. So that's, which is a square matrix, so that it will be very easy for you to understand. So hence I'm creating an array X, okay, with 1, 2 and 3, 4 as elements. So we do have a square matrix with 2 rows and 2 columns. And I'm going to create one more array because I need to add 2 matrices. So here I'm taking 4, 3 as the first row and 5, 6 as the second row. So let me save this by running. Okay, so
less than this must be integers or slice, not tuple. So, okay, I need to close this because it is understanding that it is a tuple. Okay, so what I'm doing here, I'm adding one more saying that it's a matrix. Let me run this. Okay, I have to separate this. Yeah, so it is taking that it is a matrix right now. Now let me go ahead and add two matrices. Now in order to do this, I'm going to use the same command of print. Okay, so array, which is a sum of comma, I want to add x plus y. Be cautious if at all if you have used small letters, just keep it as small letters only. If you are used capital letters, keep it as capital letters only. Take this inside. Yeah. Okay. Now in the same way, let us subtract the true matrices. So I'm going to do the same here. So instead of adding, I'm doing subtraction over here. So hence, instead of doing this, I'll give this as difference. And instead of x plus y, I'm going to give x minus 1. Okay. And I wanted to multiply the matrices here. So hence what I'm doing multiply. Okay. And instead of this, I'm taking multiply. And I'm taking asterisk over here. So this is how we can do the matrix operations by using Python. So with this, we have learned how to do a single array operations, matrix array operations, and how to create an single array operation by using NumPy package. In the next session, you'll be learning about pandas. Till then, happy learning. Let's understand what are the advantages of pandas. So pandas are fast and efficient in handling the data frame object by default. And we can also customize the indexing of those particular data frames. The tools for loading the data into a memory data objects from different file formats can be easily handled using Python. Data alignments and the integrity handling of the missing data can also be handled very well with the pandas library. Reshaping and pivoting of the datasets, label-based slicing, indexing and subsetting of large datasets. So columns from a data structure can be deleted or inserted, group by data for aggregation and transformations, high performance merging and joining of the data, and the time series functionalities can be easily handled through this Python. So with this advantages of knowing the Python, especially pandas are very good in the data cleaning process, which we'll be seeing in the later sessions where we will be going and dealing with the data pre-processing. Now, if you just look here, pandas has a capability of handling 3 types of data structures. Those are series, data frames, and the panels. So in this particular session, we'll be seeing the series and the data frame. Now, if you just look here, series is nothing but a one-dimensional array that is capable of handling all the types of the data, and a series can be created with the inputs. Now, in the next session, we are going to do a practical implementation of creating a series of A, B, C, D in Python and print the series to see the output. Without delay, let us go into the practical implementation of series on Python right now. Let us create a pandas Python series. So, series using pandas. In order to do this, first I need to import pandas library. So, import pandas as PD and let me execute this. So, the moment it got executed, I'm going to create a series. So hence, I'm calling the series as data is equal to, in order to carry out the series, I also require NumPy library because to create an array, I require NumPy library, right? So hence I'm doing so. So data is equal to np.array of a series objects A. Objects are always being represented with single inverted commas, okay, and D. And I'm calling this as data is, I'm calling this in a series is equal to pd dot series of data. And now I want to print the series. Okay. It should be capitalized. Yeah. Okay. So this is how we can create a series. Now, for example, if I want to extract the first 2 elements of the series. Okay. To do this, so what I do, I call the series is equal to pd dot, okay, I'm going to create a new object right now, which is 1, 2, 3, 4, 5. And I'm also giving indexing because to extract I require. So what does the line 1 stands for? What does the line 2 stands for? See, by default, if you don't give the indexing, Python will start taking it from 0, 1, 2, 3. But if at all, if you want the indexing to be started, so you have to give the indexing over here. So I'm saying that 1 will be of A and 2 will be of B. And similarly, 3 will be of C. Please make sure that your dimensions will match. So it should not happen that in the first series you have 5 elements and in the second series you have 4 elements. So if that is the case, it will not be in a position to understand. So hence, please make sure that the dimensions will match over here, right? And let me execute this. So PD dot, I forgot to give that, it is a series. So series, okay, yeah. Now, let us print the first 2 elements. So in order to do print the first 2 elements, what we do is print, okay. So from where you need to print from the series, that is from this particular series, you want the first 2 elements. Now, that means leaving so the colon stands for first 2 elements. So it says that for A it is 1 and for B it is 2. Let us go ahead and print the first 4 elements, okay. I'm using the same command and I'm going to create the 4 here, okay. So this is how it prints. For example, I wanted to extract the last 3 elements, okay. So in such a case, we'll be using the same command, but instead of giving the colon at the beginning, what we'll do, we will give that, I want the last 3, that is minus 3 and then the colon, okay. So the moment I print this, it gives me that 3, 4, 5. So this is how we can go ahead and extract the first and the last elements in Pandas library package and implement in Python. In the next session, we are going to look at how to create a data frame in Pandas. Now, in the practical sessions, we have seen how to handle the series. Now we are going to look into the data frames. So data frames are the 2-dimensional figures with clear labeled columns. So when the columns are numeric in nature or non-numeric in nature, so you can create certain columns. So when the columns are numeric in nature, it is very easy to carry out with the arithmetic operations. So the code to create the pandas in the pandas data frame is by using the command called data frame from the pandas lab package. So what you do is you call upon for the pandas.data frame, and wherever you have created the data frame labels will be captured over here in the data. Give the indexing, just like what we have seen in the last practical session. What does the first row should stand for, second row should stand for, and clearly give the labels to the columns, what exactly the labels you wanted, and mentioning the D type, that is a data type, whether it is an integer, whether it is a float, whether it is a string, okay, and then give the copy of this particular data frame, right? So this is how we can implement the data frame in Python. Now, let us go ahead and create a data frame with the student name and the marks obtained. So this will be done by using the Python Jupyter Notebook. So let us go into that session right now. Now what I do is I'll just go ahead and take the new Python file and I'm going to create a data frame for this. So hence what I'm doing, I'm creating pandas data frame. For this, first of all, I require both the libraries as NP and I require both pandas as PD. Remember, the moment you take the new sheet, it is required to call upon for these particular packages. Sorry, I have to take pandas as PD. Right? Now, the moment I call this, now what is my job? My job is to go ahead and create a data frame with the student name and the marks obtained. So creating a data frame with student name and the marks obtained. Now to do so, what we'll do is we call upon for data, which is equal to, now you have to give both indexing and then. So what I'm doing, I'm taking Alex and the marks obtained by Alex is 10 marks. Okay. Now I'm creating like this. So I'm giving Aaron and the marks obtained is 13. And again, I'm creating one more. It's Lucy, who has got the marks of 15. Now, I wanted to see this entire data into a column and a row format. So that is what. So how to do that? So to do that, I need a data frame package. So hence what I'm doing, I'm calling as data frame is equal to pd.data frame. Be cautious with this. So your D should be capital and your F should be capital. And all my columns and rows are being defined in data. And I want the columns to be, the label of the column should be the name of the student and the marks obtained. So this is how my table should look like. So my first column should contain name, my second column should contain marks. So under the names column, I want Alex, Aaron, and Lucy. Under the marks and the marks obtained by these particular students. So this is what I just wanted to give it. So what I'll do, I'll just mention this as this is a columns over here. I'm just mentioning that these are the 2 columns. Okay. And I'm going to print df function right now. Okay. I should give brackets to df. Yes. So this is how you can go ahead and create a data frame where you can extract the marks and the name of the students. Now let us go ahead and create a data frame with the indices right now. So now creating data frame with indices.
Now to create this, what I'll do, I want row index, I want the column index. I have already imported the data file. So now I'll just name it as data_1. These names you can give it. This is up to you to decide. So I'm just taking this. And to give the index, always use the flower brackets. I'm giving this as 1. Okay, let me take BC. There is nothing wrong in taking capitals also. So need not worry about this 1. Okay, I'm creating this. And I'm also saying that CDE should be taken as 2. Okay, this is one frame which I have created. That is a 1 column. And again, what I'm doing, I'm saying that I want the same ABC to be indexed with a 5. Okay, and then C. Okay, let me change this because it is ABC. And I have to close this. Okay, and CDE, and it should be of 10. Okay, and EFG should be equivalent to 20. So what I did, I created a data frame here. Okay, it says invalid syntax. So let's see, where did we go wrong? Yes, here I gave equal to, so I should give colon. Yeah. Okay, now I have created data _1. Now I want to index the columns. So what I'm doing, I want indexing of the columns. So hence what I'm doing here, I'm creating a data frame 1, which is where I require the package of data frame. Okay, I am taking data _1. Okay, index the columns as first, comma, second, right? And I want the column names. So columns is equal to, I want that to be with capital A, and this would be, let's see whether this works. Okay, what is that? 2 columns passed data has 3 columns. Yeah, if you see here, we have 1, 2, 3 columns here. So hence let us go ahead and define one more column. Let's see whether this works. Yes. So here I have defined 3 columns, but here while I've mentioned 2 columns, hence it has thrown me an error. Right? Now let's go ahead and print data _1. I'm sorry, I should give the parenthesis to print command. Yes. Okay. And I'm also going to print the data frame 1. Yeah. So if you see here under the data frame 1, it captures 2 things. One is CDE 2 with ABC and ABC 1. And see, we have not given any command over here, and hence it is giving none. So the moment if we give something over here, let's go ahead and give one more. I'll give it as a GHF. Okay, and I'll say that carry this as 3. Okay, let us implement this. So I'm running the same lines. So now it creates this ABC as 1, 2, 3. Right? So this is how you can implement the data frames or create the data frames using Pandas library. Thank you all. Matplotlib package. This is the package which is used to come out with the mathematical plots. Okay, so whenever we wanted to come out with the mathematical plots, there are different kinds of plots which we will be using, like bar graph or histogram or scatter plot, area plot, or pie plot. So every plot has its own requisites, right? So depending on the requisites of the plot, we will be choosing the right plot for the visualization. So hence, in order to visualize the data by using certain graphs or plots, we use matplotlib function. Now, we will be seeing the same data visualization by using the matplotlib function in Python under the module of data visualization. Now, apart from this, sometimes what happens is we may need to go ahead and get a pair plot. That means I have multiple columns. I wanted to visualize all the columns together, right? So in such a case, what we do is we go ahead with another package called as Seaborn. Now, Seaborn enables you to do the data visualization, and it supports the other 2 packages of NumPy and Pandas in visualizing. So it also helps you for a pair plot and efficient visualizations. Now, whenever I say it as a pair plot, so it helps you to visualize 2 columns together. Okay, or it also enables you to go ahead and get a 3D visualizations. So I have 3 columns. I have sales, I have price, I have cost. So I have to see, all these 3 columns together. So in such a case, we will go ahead with a Seaborn package. So these are the packages which are available in Python for the data visualization. So of course, which we will be seeing practically in the module of data visualization module. So till then, happy learning, and see you in the next session where the package we will be discussing about in the next session is about scikit-learn. Thank you. Welcome to the session on scikit-learn and TensorFlow. Scikit-learn is a package or which is being represented in a short form as the sklearn. It is the science parameters which will be enabled over here. This sklearn package will enable you to build the machine learning algorithms, and it helps you to validate the machine learning algorithms based on the model diagnostics. So it helps in shaping of the data, and it helps in identifying the feature selection process. So hence, sklearn is one of the most important package which is used to build the machine learning models. The further machine learning models will be studied or will be considered, in your next sessions. Now, along with sklearn, we have a package called TensorFlow. Now, what is the use of this TensorFlow? So, TensorFlow works or enables you to do the work specifically to the deep neural networks. So, these are the algorithms which have some sort of memory storage, and it requires high-end processing with the large volumes of the data. Hence, this helps you to build the neural networks where the learning parameters can be set and enables to go ahead and implement the artificial intelligence. So hence, along with the TensorFlow, you may also sometimes require Keras package to go ahead with the deep learning networks. And it also helps you to do some sort of wave transformations whenever you are looking at some sort of data sets in identifying the hidden states within. So these are the functions of TensorFlow and the sklearn. So with this, we have learned about the different packages which are popularly used in Python, starting from NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn along with TensorFlow. So see you in the next session. Till then, happy learning.
Hello everyone and welcome to the session. In this session, we will talk about object-oriented programming in Python. So let's start. Python is a multi-paradigm programming language, meaning it supports different programming approaches. We know Python is a multi-paradigm programming language. It supports object-oriented concept as well as procedure-oriented concept as well. One of the popular approach to solve a programming problem is by creating objects. This is known as object-oriented programming. Object-oriented programming is a popular approach to solve a programming problem by creating object, and the concept of creating object is considered as object. Object-oriented programming deals with classes, creating objects from them, and interaction with the user. So these are the topics to be covered in following sessions. So what is Python class? A class is a code template, or you can say a template of code which helps in creating objects. Objects are nothing but a member variable. An object of a class has member variables, and their behavior are associated with the class. Suppose in Python, if we want to create a class, so we have to use class keyword. An object inside a class is created using a constructor. This object will then be called as an instance of a class. Suppose if we want to create an object of any class, then with the help of a constructor, we will create that object, and that object is called an instance of the class. Why we want to use a class? Using class, you can add consistency to your code, and the code looks cleaner and more efficient. Class is a variable that is shared by all different instances of a class. Inside a class, we can define as many methods or variables as we want. Instance variables are variables which are unique to each instance. It is defined inside a method and belongs only to the current instance of a class. Suppose I created 4 different objects inside a class. The instance variable for all these 4 objects will be unique, which is defined inside a method. Methods are also called functions, which are defined inside a class and describes the behavior of that object. There is no such major difference between method and function. Function doesn't have much difference. The simple difference is the method are defined inside a class and functions are defined outside the class. Now let's see how to create class using a program. So if we have to define a class in Python, then we will use a keyword called class. So here I will create a class. Here we will give class name as car. Okay. So here I created a class named car. So inside this, I want to define some properties. Before defining some properties, let's make a class an empty class. So we will just write pass. We'll just write pass here. So as of now, it doesn't have any properties. Now we can initialize an object from this class. In short, class car is basically a blueprint here. So instances can be created from this class. If I consider one car as one class, you can have any number of classes which can be instantiated from that particular class. So let's see how to instantiate from class. So here we will write car1 as one object and pass car here, double quote, yeah, brackets, double brackets. So the car, we have passed class car to this object car1. Now we will execute this. So if let's see it's perfectly executing or not. Yeah, if we print here car1, see the car object is basically created at this location in the memory. there is a good inbuilt function present in Python. So let's see here. If I write dir of car1, see, you can see number of inbuilt functions. You can see a good inbuilt function here as init. So init is nothing but basically acts as a constructor. So this init function basically acts as a constructor. A constructor basically gets used in order to initialize how many number of properties are getting used inside that particular class. Now let's call this particular constructor. So inside class car, we will here and call define underscore init underscore pass self here first. Inside that, you will use self parameter. This parameter plays a very important role. We will see in few moments what this self does. It is possible that you need to provide how many parameters it is going to consider inside that particular class. So let's consider 3 parameters: windows, door, and engine type. So besides self, we will give windows, doors, and engine type. So these parameters are related to the class car. Car has windows, doors, and engine type is petrol or diesel. Now let's start creating attributes. For doing that, we will use self attribute. Self is basically directing to a particular object. So we'll write inside that self dot window equals to windows similar place. So the self here is directly what we can say. So this self is directing to this car1. So all these attributes will be directed to car1. When we call this car1 function, all these attributes will be directed to this car1 object. Here's the attribute window is getting assigned the windows value. So whatever the values inside this windows will be assigned to window. Currently we haven't provided any values to this car function. So if we run this, it will give an error missing 3 positional arguments. So windows, doors, and engine type. We haven't currently provided it. Now we will provide the values. So number of windows is 4, doors are 5, and engine type is petrol. Now if we execute this, so what will happen? So we are not getting error now. It's executed. But by default the init method is called here. Because it is my constructor, so it will initialize my variable or attribute and assign the values to the parameters. So by default, the car1 is calling init function. So inside this init function, all these parameters will be substituted. So that's why we are not getting error now. It's perfectly executing. Now let's create a method. Define by name self-driving. So underscore driving and provide self to it. So this self will have access to all this init function inside the constructor. Now we provide return. It will simply return acts as a print statement. Return this is car videos for dot format and provide parameters self, engine type. Sorry. Now we will execute. We will provide parameter self.engine type. Now we will execute. Still not giving. Sorry, I forgot to mention that we have to call that self-driving function. So here we will call car1 dot self underscore driving. So you are getting the output here. So this is the petrol car. So I hope you got the idea how to create a class and methods inside a class. So next we will see inheritance. Thank you. Hello and welcome to this session. Today we will discuss about Python inheritance. So what is inheritance? If we use method, variables, and function of a class in other class, this is called inheritance. It means if I use a property of one class in some other class, so it is called inheritance. So here I have two classes, class A and class B. Class A is a base class and class B is a derived class. here I have class A as a parent class whose properties we have to use. That properties of a parent class will be inherited by a child class, in which case class B here is a child class. Now we will see how we can derive properties of base class into its derived class. So here is a syntax for inheritance. Here I have a base class as a parent class and derived class as a child class, and pass base class as a parameter to derived class. In this derived class, I have to inherit properties of base class. So inside parentheses, I wrote base class. The derived class will inherit features of base class and add new features also. It will help in reusability of code and also help reduce the program length, and execution time will be faster. Now we will see an example to understand inheritance better. Firstly, we will define a superclass named user. Class user. Now we will declare a variable called name, and which is a blank string. Now we will create a constructor and pass arguments such as self and name to it. Define underscore init self and self equals to name. Here the value of name will be stored in this name. Now I will create a method print name which will function as print statement. And pass self to it. Print. Now we will create an object called brain and pass class user as class user and assign user to brain. And inside this parenthesis, I will write brain, and this brain will be inherited here. Now I will write call. Now we will call print name function. Print. Sorry. What will it return is name equals to brain in output, because we are giving argument as brain. So let's run it now. See, you can see brain is printed here. This is a parent class. Now we'll create the subclass or the derived class. You can see class. So here we are creating a derived class and giving user to it. So it will inherit the properties of user and use it. Now we'll define a constructor to it. Define underscore init pass self command name, then self name equals to name. So we have defined a constructor and pass self and name to it, say as parameter. Now we will create another method here, to Python self print. We'll simply use print here. Now we have created a superclass and a subclass. So class user is a superclass and class programmer is a subclass, using inheriting the class user's properties. Now we will see if inheritance is working or not. Now I will create an object named as var pr equals to pass user Veronica. So it will use class user class, parent class, and sorry, vr dot print name. Similarly, for subclass sb equals to programmer, and we'll give Freddy to it, and sb dot print name. So here I have called a method print name which is in user class. So it will direct use print name method from the user class, and we'll call sb dot do Python method. Now we will see the output. Yeah, we have to run this class first. Okay. Yeah. So you can see the outputs here. Brain we have used in the user class. Similarly, Veronica for the user class. Now Freddy we have passed in the subclass here, but it is using print name which is in user class. So it's executing perfectly. So this is inheritance. Now we will see types of inheritance. So types of inheritance is a single inheritance, multi-level inheritance, and multiple. So example of single inheritance you just saw. We will now see multi-level inheritance. So multi-level inheritance. In multi-level inheritance, we inherit the classes at multiple separate levels. We have three classes A, B, and C, where A is a superclass, B is its subclass, and C is a subclass of D. So we will see an example to clearly understand it. So here is the example. So I have created a class named animal and added a method name eat to it, and that method is simply printing eating. Similarly, another class named dog and it inherited class animal inside the dog class. So here I have created a subclass named dog and it has inherited properties of animal class. Similarly, class baby dog. So this is a subclass of B. So it has inherited the properties of dog class and defined wave. So if we run this program, okay, it's connecting. So here I have created an object D and provided the class baby dog here. So d.eat, it will access the eat method. I have access to the bark method and similarly have access to the weave method. So you are getting the output here. So this is multi-level inheritance. Now multiple inheritance. Multiple inheritance is when a class can inherit attributes and method from one parent class. Okay, so here there are two parent classes, parent class A and class B, and a child class. So child class C will have both attributes from class A and class B. So let's see an example to understand it. Here I have created a class A and defined a constructor to it, self.name, and provided attributes Atul and age. Similarly, and defined a method getName self, it will take the name Atul here. Similarly, class B provided defined a constructor same as class A and class A, and here class C, inside class C I have provided class, it has access to class A as well as class B. So inside the constructor I have called the init function of A and init function of the constructor of A and constructor of B. So it will have access to both the constructor functions of A and B class, and define a method called getName. Okay, so I have created here an object called C1 and provided class C to it. So when we print C1.getName, it will get Vivek. So here what happens is class B overrules the class A attribute. When we in multiple inheritance, class B will overrule the attribute of class A. So that's why Vivek is printed here, not Atul. So this was all about inheritance. Next we will see polymorphism. Thank you. Hello and welcome. Now we will see polymorphism. Polymorphism is an ability to use common interface for multiple methods. It means same function name but with different signature being used for different data types. It means that same function name can be used but with respect to different data types. So let's see an example. Let's take a list containing numbers. Here I have created a list L and passed 40, 50, 60 numbers and print, and similarly a string with welcome. In order to see the output, I have passed a length function to the print statement. So it will return the length of the list and the string. Let's see how polymorphism is used here. Here in length function, once we passed a list, then a string. Here the function remains same and the signature is different. That means data type is different. For the string it has different data type and for the list it has different data types. This concept is called polymorphism. Let's see an example. Let's understand polymorphism using example. Here I have created a class parrot and assigned a method called fly. So in this method it will print parrot can fly. Similarly, a different method swim named swim. I have defined another class called penguin. I have defined a method fly and swim for the same. So here you can see we have defined two methods having same. So defined fly method is present in both class penguin and as well as parrot. Similarly, swim is present in penguin and in parrot class. Now here I have defined a flying test which is a common interface for both class parrot and a class penguin, and provided a bird parameter to it and used fly function. So it will access both fly statement of fly methods of class penguin and class parrot. Now I have created here an object PR and assigned parrot to it, and similarly PG and assigned penguin to it. Now we'll test it. Now calling a method flying test and pass PR and PG to it. Now we will see the output of this code. So you can see parrot can fly and penguin can't fly. So it's giving us the output. So it is accessing both fly methods of class parrot and class penguin. So this is polymorphism. So now next we will see encapsulation. Thank you. Welcome. Now we will see what is encapsulation. Using OOPS in Python, we can restrict access to methods and variables. What it means is, using OOPS concept, we can restrict method, variables, and function from any class. Because when we use inheritance, the subclass have all the access. Subclass can access every method, variable, and function of the superclass. So if we want to restrict such action, then it can be done with encapsulation. So it is called encapsulation. So this prevents data from direct modification, which is called encapsulation. This makes our code private and protected. So not everyone can access that code and do modification to it willingly. If we want to make any method or variable protected, I will use a single underscore in prefix of a method or a variable. Similarly, if I want to make any method or variable or function private, then we will use double underscore in prefix in the method or variable. If no underscore is given, then it is a public class. Now let us understand with example what is encapsulation. Here I have created a class named computer and created a constructor and provided an argument self. With self I have provided the max speed here as 120. It is a private class, so it is given underscore max speed, so it is a private class, private method. Now I have created a method and which simply is a print statement. Similarly, I have defined a setter method and provided parameters self and price to it. Here I have created an object and assigned computer to it. So q.cell, it will access q.cell. So if we want to change the speed, so I have assigned q dot double underscore max speed equals to 150 and q.cell. If we run this, so it will print 120, the actual speed. It will still print 120 because it is a private method. It will not change the speed from 120 to 150 because it is a private method, so it cannot access this. So it will simply print 120. So using setter function, we can change the speed. So what is a setter function? Using setter function, we can change the value of a private variables. If we want to assign a different value to the private variable or method, we have to use a setter function. So that's what we have done here. Define a setter function to change the private value of a private variable or a method. So this is encapsulation. Yeah. Thank you.